This is section 5-2. We're on page 229, and today we're going to be talking about polynomials. So what is a polynomial? A polynomial is a monomial or a sum of monomials. For example, 3x. It may be just a monomial, but it's also considered a polynomial. Another example is 3y plus 6. Two monomials added together. Or 12y plus 6r. So a polynomial has to be a sum of unlike monomials that you can't combine. Okay, so now another vocab word is a term. The monomials that make up a polynomial are the terms. So if we have 3y plus 6, there's two terms here. There's 3y and there's 6. So they're each called a term. Now, like terms. Like terms are two or more monomials that can be combined. So if we have 3y plus 5y plus 6, the 3y and 5y can be combined. So that would be 8y plus 6. So the like terms are the 3y plus 5y. Okay, now a trinomial. Tri means three, so that is a polynomial with three unlike terms, such as 3y plus 6x plus 12. We can't combine any of those terms, so that is a trinomial. And the next we have is a binomial. Bi means two, so that would be 3r plus 7. That's a binomial, two unlike terms. And the last one is that we're going to talk about is the degree of a polynomial. Okay, so the degree of a polynomial is the degree of the monomial with the greatest degree. Okay, that breaks every rule of defining a word by using it two other times in the definition. So what does that actually mean? So if we have 3x squared plus 7y squared r squared plus 9. So let's look at each monomial. The first one is 3x squared. So that is a second degree monomial. The second term is 7y squared r squared. And remember, when we figure out the degree of a monomial, we add the exponents of the variables. So we have 2 plus 2. So this one's a fourth degree. And then 9 doesn't have a degree. So we would say that 3x squared plus 7y squared r squared is a fourth degree polynomial. Okay, so that's a fourth degree polynomial. So let's look at another example of a degree of a polynomial. I have 1/6 x cubed y to the 5th minus 9x to the 4th. The first thing we need to determine, is this a polynomial or not? It is. It doesn't break any of the rules. We don't have any variables in the denominator, we don't have any negative exponents, and we do not have any radicals with a variable underneath of it. Okay, so let's figure out the degrees of each term. So this is a binomial because we have two terms. Our first term, 1/6 x cubed y to the 5th. So remember, we add our exponents of our variables. So this is an 8th degree for the first term. The second term is minus 9x to the 4th. So that is a 4th degree monomial. So we say this is an 8th degree polynomial because we take the higher one. Okay, now let's look at our second example, is x plus the square root of x plus 5. Well, this isn't even a polynomial because we have a variable under a square root. So this is not a polynomial. Cross that guy out, and we don't do anything with it. Okay. Now we're going to subtract and simplify a couple of polynomials. So what we have is open paren 3x squared minus 2x plus 3, close parentheses, minus open paren x squared plus 4x minus 2, close paren. So the first step we need to do is look at this minus sign. So this is the first monomial polynomial subtracting that whole second one. So the first thing we need to do is distribute this negative sign to everything inside the second set of parentheses. So what we end up with is 3x squared minus 2x plus 3, taking it out of the parentheses, and distributing that minus sign to everything. So we have minus 1 times x squared, so we get minus x squared. Then minus 1 times our second term, which is plus 4x, so we get minus 4x. And the last one is minus 1 times negative 2, so we get a plus 2. Okay, so now we have 3x squared minus 2x plus 3 minus x squared minus 4x plus 2. So combining like terms. Using the commutative property, let's put all like terms together. So we have 3x squared and a minus x squared. So I'm going to rewrite that as open paren 3x squared minus x squared close paren. And now we're going to look at our next level down, which are our x's. So then we get plus open paren minus 2x minus 4x, close paren. And then we have a plus 3 and a plus 2. So we get plus open paren 3 plus 2, close paren. And now let's combine our like terms. To start with, we have 3x squared minus x squared. We get 2x squared. And then we have a minus 2x minus 4x, which gives us a minus 6x. And last, a 3 plus 2, which is a plus 5. And that it would be our answer. 2x squared minus 6x plus 5. Okay, so the last thing we're going to talk about are multiplying polynomials. When we multiply a polynomial, we have to use the distributive property. So if we have a problem like 2x, open, 7x squared minus 3x plus 5, close paren, we have this 2x outside of our parentheses. So we need to distribute that to everything inside of the parentheses. All right, so the first one we have 2x times 7x squared, which gives us 14x to the third. 2x times negative 3x gives us minus 6x squared. And last we have 2x times positive 5, so we get plus 10x. And that's the end of it. So that is a trinomial with a third degree of 14x cubed minus 6x squared plus 10x.